All right, so today's plan was to walk through the A* algorithm for pathing, so players can move from point A to point B, and they can get around obstacles. And I found a decent implementation, and I tried to port it, or not really port it, but just translate it from the Go library that was written to the one that I was going to use. And some things happened, and long story short, my version is like 3 to 4 times slower, and I cannot and could not figure out why. So I've been debugging for the past, I don't know, hour or so, trying to figure out what's going on. But before that, let's take a look at what this whole thing does. So if you're not familiar with the A* algorithm, it's kind of based off of Dijkstra's algorithm, which is a graph pathfinding. Just checks the nearest neighbors and then tries to the next one, and there's some stacks in play here that kind of keep track of where you visited and where you've been and what your obstacles are and where you can and can't go. So there's a lot going on. I don't 100%, like if you asked me to write the algorithm just looking at the paper for it, I probably couldn't do it. But I was able to find a decent one, and I checked it and it worked. I was able to go through my levels and actually print out the proper paths for a certain character, like clicks. So it seemed really, really good. And then I'm like, all right, let's benchmark this thing, because again, if we have 10,000 clients, I want to make sure that the pathing isn't going to take a ridiculous amount of time. And when I first ran, I was like, 10,000, that's not too bad. So I can do 10,000 path checks in a second, which is great. But then I was like, well, let me check what the original library does. And it does like 38,000 path checks in a second. So I'm like, damn, that's weird. What's going on there? Because the algorithm that I copied is almost the exact same thing. So this github.com jpierre, actually let me bring up that person's github.com. Where is it? Point level maps. That's where I'm not importing. Oh, right, I'm not importing. This is my test. This one, A*. So if we look at this one, it's only got like 24 stars. I don't know. It just happened to match my exact structure of a XY grid. Very similar setup. Let me make this bigger here. Zoom in some more. It had obstacle nodes. I'm like, oh, this is like perfect. This is exactly what I need. But they use nodes, and I'm like, well, I have my points, and I just want to keep my point stuff. And I figured by kind of taking it and putting it into my code, I would be able to understand it better, which it definitely helped, because it's not exactly straightforward. But yeah, so once I got it in, I made sure it worked, and then I started to do some benchmarks, and that's where things got kind of weird. So let's just do a debug session real quick of getting a path. So this is getting a path from x of 0, y to 7 to 5 to 5 to x5, y5. So it's going to move kind of that way. And let's just fail this test so it prints out. If we run the test, you can see that it goes from 0 to 6 to 1 to 6 to 2 to 6 to 3 to 6 to 4 to 6 and so on until it gets to the destination, which is great. I was like, yep, that's exactly what I want. And then I went to benchmark it, and I noticed this, and I was like, okay, that's kind of weird. And I was like, well, how about the memory? Is the memory like the same, or am I allocating more? Like, why is this doing this? And yeah, it's allocating more memory too. Not too much, but there's definitely more allocations going on in mine. And if we walk through their code, so they have this config that kind of loads the grid width and height, the invalid nodes, which in my case are unwalkable, weighted nodes, which I don't have, but it's kind of a nice to have, so you could add more weight to a particular node. So if you say this is like sludge, it should take longer, so there'd be a higher cost. You wouldn't want to go through it. You'd want to path around that, so you'd take that into consideration with your pathing. It's pretty basic. On initialization, it adds the configuration nodes to this list. It's a custom, just a list of node structs, slice of nodes rather. Their nodes are pretty similar to mine, X, Y. They have these F, G, and H's, which are part of the weighting, as well as the part of the distance calculations. So you'd want to it does like a Manhattan distance between 2 points to figure out a priority of which way to go. So that's really nice. But so yeah, this list just adds nodes, and they're not using pointers. So it's like, so at first I tried to just use pointers everywhere. I was like, well, maybe I can get better performance by passing pointers instead of passing these nodes across. But that, again, with structs, it doesn't really matter. There's no real cost there. Yeah, removing, and actually this is, in their case, it doesn't spend much time in this get index, but in my version it does. But my code is exactly the same. So here's my translation of it. And by translation, I mean copy and changing nodes to points. So it's like exactly the same thing. Get index. Oops, where's the get index? There it is. Get index, same exact thing. So again, looking at their code, contains, everything else is very straightforward except for this index of min f, or f is the kind of that calculation of priority. And yeah, and it gets min node, and then it returns the node at that index, and that's basically how that list works, which is fine. This is the distance between node A and node B. This is the Manhattan distance I was just mentioning. Get neighbor node. So this is where it checks if it can go up, or if it can go left or right or down, and then it checks if they're accessible, and if it is, it adds it to a neighbor nodes, and this is all done on a loop, so it's going to keep adding to these neighbor node lists. And then the is accessible. So they are using an object property, instance property. So they have closed lists bound to this A star structure or object, whereas in my case I don't. So what I'm doing, well, I kind of do now because I added it for testing, but before I was basically, I wanted my level to be immutable. So you'll see that I'm not using pointer methods because I didn't want to write to this class. I wanted it to be immutable, and I figured that would be faster, but I guess it turns out not. So yeah, in my case, instead of making it an object instance, I was adding it to the inside of the first call to get the path. It would just create a new set of points, add the unwalkable ones, or the closed list, or what do you want to call it. And then it'll go through the same exact process of checking if there's anything left to, if any of the nearest neighbors are still there, getting the next prioritized node to look at, removing it from the open points, adding it to the closed points because you don't want to traverse it again, so you just add it to that list. And if you found the end of it, if the current point is the destination, you got your path and you're done. So in this case, in their case, this is where it kind of begins to differ, where in their there's this called find path. They use, again, the object instance property of the lists to get all this information. They never pass these lists. They're all part of the object itself. Does the get neighbor nodes, checks the node, and then it checks all the neighbors and calculates the priority. And then if it doesn't contain it already, it adds to it. So pretty straightforward. Here's the calculation of just like adding some variables together, doing the Manhattan distance, adding those together, and then that's the, yeah. So, and then get node path is what's executed at the end. So there's no, basically the hot path is get neighbor nodes. So this is where the majority of the work is being done because it needs to look at every node around the current one you're in. So this is where the work's being done. So I figured that's where I should investigate first, and I looked at is accessible, and for some reason their contains is just not getting called nearly as much as mine. And if we do a benchmark with CPU, let's do it. Yeah, we're doing a CPU profile, and then we're going to, I could probably just use the old one. We are going to look at, I'll explain that stuff in a second. CPU prof. So that benchmarked both of them at the same time, and you'll see mine spends the majority of the time in point get index. Theirs spends the majority of the time in runtime grow slice. So it's like their version of where's theirs? Get neighbor nodes. They go to, where's theirs? I'll make this bigger. Get neighbor nodes. There should be a get index somewhere around here. Hold on, I gotta zoom out. Where is it even like? Oh, there, it's like way over here. It's like spending 3% of the time in the get index method. So that's super weird. It's like, what the heck is the difference between mine, which is just getting hammered going through that points slice or list. And I found out what it was, but I don't know why. So if we look at my version, remember I said that I was calling it from here. So I was like, okay, maybe it's just the allocations. Maybe it's just because I'm allocating in here. So I disabled this, and then I set this to the one I created at the object. When I create the level, it will create these points for me. And then I'm going to actually, no, I'm going to use the one where I don't pass. So I'm going to use it just exactly like theirs. So theirs is pretty much like this, where I have the L close points, calculate node, and then get neighbor node. So it's going to follow the same exact flow that the original author's library did. And I'm going to run the benchmark again. And you can see now I have like 860,000 iterations in a second. I don't know why. I think I'm still... Yep, I'm doing everything almost exactly the same. If we look at the benchmark code with Go's benchmarks, for my version, what I do is I create a new game level. Oh yeah, that's why, because I'm creating the game level here outside. So that's going to impact the timing. So what we're going to do actually is, let's make this more realistic. We're going to create the new level every time. We are going to, let's just do this. I'm going to do a random point for the start, and we're going to do a random point for the ends. So it'll just choose randomly 2 points to try to find a path for. And I guess we don't need this anymore. So let's rerun. If I rerun this benchmark and it doesn't have almost exactly the same number of iterations in the second, I'm going to be super surprised. All right, 10,000. No, so now I'm even lower. Okay, yeah, because I'm creating. Nope, I don't know why that happened. Oh, because I'm still allocating inside of the game or get cell. So the big difference. No, I'm not. I no longer do that. So again, there's a lot of weird stuff going on here that I don't really understand. Okay, so, and if we look at their benchmark of A*, they have their obstacle nodes, which I basically disabled because I wanted to test. I mean, that's actually one of the reasons that mine is slower, is my map has more points where the player can't go through. So it needs to check a list of 45 points to see if the player can actually traverse. So when you, actually I could probably demonstrate it with my get path debug session. So let's debug this real quick and I'll show you what I'm talking about. So we're going to hop into here, hop past here. Let's make this a little bigger. And we're just going to go to the points section. So get neighbor nodes. We're going to go into is walkable past, or close point just contains. So contains. So if we set a breakpoint on the get index, so this is, oh, it already has one. This is going to show us how much data is in ours. And I can't get this to go away. Why are you so big? There we go. Go away. Go away. Go away. Okay. So inside of my list of, oh no, sorry, I want to be in points first. So let's make that go. So this is the open list. So there's nothing, this is just the first node that it's traversing. The next one should be the closed list. And you'll see that now the list of points it has to go through is a lot higher, which makes sense because, yeah, there's 57 total points, unwalkable areas within that map. So that all makes sense. So yeah, everything makes sense there. So if we stop this and then we go to their version and we look at their get index, we're going to see a lot less. Test A star. We're gonna, this one, actually no, this one does have obstacles, so I will comment that out. Debug test. So it should be the same. The first one should not have, it should only have 0, and the next one should have like 0 or whatever. Yeah, it only has 1 for the closed list. So that's why mine was slower, because their list is a lot smaller. It doesn't have any obstacles in the way. Again, this all makes sense. I'm fine with that. Mine has more work to do, so of course the benchmark's going to be off. But what I don't understand is if I move away from using it as a object instance, the list, if I move it as using a, basically this is going to create a pointer of new points, add the unwalkables, or the places the path can't go to, and then I'm going to pass it across every method. So it should just be passing a pointer to all these things, and that should be it. That should all it's doing. It shouldn't be doing anything extra. So if we're going to go to L, get neighbors, and this time we're going to do pass. So we're going to pass. I'm used to typing password. I wonder why. Closed points. So now we're going to pass it to this version, which just takes in the closed points. It calls is walkable passed, which does pretty much the same thing, but instead of calling it as an object instance property, it's just going to call it as the one that was passed in over the function. And then we're going to benchmark it. So a little bit better, but still not great. Like, all I'm doing is passing a pointer. It shouldn't do anything extra. Like, again, if we go back and we call the old version where we don't pass it, we just call it as a property instance, l.closepoints, l.closepoints. Oh yeah, this is passed. Oh no, yeah. Oh no, yes, yeah. We're gonna test it as just passing it in object instance first. We're gonna comment this out. Oop. We're going to uncomment that. So now we have our points here. Use the object instance version. So now close points should all be using that one. Okay, good. Rerun the benchmark. Whoa, now it's even worse. Now I'm super confused. Huh. Okay, let's try not passing it. Let's just try using the object instance. So now we're going to, do we want to do that? Oh, I'm sorry, I already had I don't need to add it again. It's already added in the object creation. So that's why it wasn't as bad. Okay. Now, we're going to try just doing it without passing it. So we're going to just call in, go back to L close point. Yep, that's all fine. So now we're going to call into is walkable. And then is this one right here. So we're just going to call the instance version of it. Benchmark it. Okay, now I'm getting totally different results than I was getting before, probably because what I wasn't doing before was creating the map every time I ran the benchmark. That was probably the biggest difference, because now I'm creating the level. So I guess mine's just slower, but I don't understand why. So this makes things super interesting. I mean, I guess part of the issue, I don't like that I'm calling random generation in mine and I'm not in theirs. I mean, I don't think let's try it. Let's just let's go back to using from here. Call that one. So this is going to create these guys first. I mean, it shouldn't matter. But starts I, ends I. Oh, I don't have a level. Well, I'm pretty sure the width is 15 or 19 and the height is 15. So we'll just do it this way. All right, so now we're pre-generating the random values and then just passing in them into the cells. So this is the number of iterations. It's just going to pass it in. It shouldn't be too much of a difference, but you never know. It's even worse. What? That makes even less sense. I clearly must be doing something wrong. Now I'm getting 8,000 iterations. This is just bizarre. Okay, let's think about this. Create the game level, get our spawn points, create our close points, we add the unwalkables to it, and then we go back and then we're pre-generating our random start points, creating our level. Yep, we already did that. Get path from cells with the start and end points. So, I mean, one thing I could do is create a completely empty map, just like I'm using for their benchmark. I mean, it's just to remove more variables from it. It's the only thing I can think of, because like everything else is exactly the same. Can I do that easily? Yeah, I can. I can totally do that. I am going to go to my level 1. Where is level map? Now we're going to make a level 2 map. It's going to be level 2, and we're going to replace all walls with open slots. Place all those, and I think I have some CLs. Yeah, those aren't. I think that means unwalkable. So we're going to replace that too. Okay. So this is our level 2 map that's totally open. Go back here. Our level 2 map. Oh, yeah, just gotta do this. Okay. So now we have our level 2 map, and I'll pop it into what I call new game level, which is test. Benchmark get path level 2 map. Let's see if this changes anything. If it doesn't, doesn't. Of course it doesn't. Why? Why is it doing that? Just checking my messages from a friend who just popped in. Anyways, yeah, this is super, super weird. So one thing that I wanted to do is like to figure out the difference is to look at how the compiler was spitting it out, but now I'm like just so confused that I don't even think it's worth it. I think there's something terribly wrong with how my implementation works, because this is just breaking me. So we have a level map, add our unwalkables, which actually in our case should be very small now that we changed it to a, yeah, let's try this up here too in our normal test. Level 2 map, debug test. I want to look at those indexes again. So unwalkables should be super empty, and it is perfect. Okay, so if it's, that's fine. Then when it does this should be empty too. Or this, yeah, that's the first, that's the open one, and the closed one, yep. So everything's fine there. It should be exactly the same. So now, if we look at the memory profile, or the CPU profile, I mean, it should be, so A star, their version again, spends some of their time in get neighbor nodes. Most of it spent in allocations. Their get index is very small, 6%. Whereas mine is game level. Oh, this is very different though. Before I had spending most of my time in is walkable. It's still spending more time though. 16% versus their 6%. Alright, so where am I spending most of my time? Get path from cells. Oh, new game level. Ah, dang it. It's including that into the benchmark. Which, I mean, if I had to generate it every time. That's weird that their setup is... Oh, because I'm also doing other work, like looking through the map and doing some work there, which they don't have to do. They're just taking the grid and that's it. That's their entire initialization. So their ads take 16%. My get neighbor nodes is 17%. Yeah, I mean, that's still super weird. Why is mine so much higher? And just to confirm, I am doing it by the function or the object instance and not, yeah, I'm not allocating. I mean, does it matter that this is? What if we move open points to a, let's try open points, points. I haven't actually defined that. Open points dot points. So now we're going to do that, initialize it there. We're going to remove it from when we call the method, and we're just going to reference the object one. Anyways, I will show some of the decompiler stuff because it's pretty awesome. And if you've ever used Go before, you should totally know how to do it. But I'll do that in a second once I figure out what the heck is going on here. Alright, so now open points, get neighbor nodes, everything should be referencing this we don't care about right now, we don't care about that. Is walkable, yep. Get node path, yep. Okay, so now what happens if we benchmark? Probably nothing, because this makes, yeah, it doesn't make a difference. Huh. Alright, what if we look at our memory profile? Let's try that. Benchmark that. Level generate points is generating a lot, using a lot of data. Oop. That's weird. Whoa, why is it cutting off half of it? Refresh. Okay. Nope. I just messed it up again. Whatever. Okay, so generate level points. Get neighbor node. So that's taking 100 and 100. That's doing, adding is doing the most of the majority of the allocations, which makes sense. Get neighbor nodes does that. Get node path. I don't see anything too crazy here. If we view, yeah, so their ad. So mine just seems like they're being able to pump out a lot more because they can iterate more. So that's why their allocation numbers are higher than mine. This is very strange. Okay, so where do we go from here? How do I get my allocation or my benchmark better? I feel like I'm kind of stuck because it's literally like 4 times worse and I don't know why. Where to go from here? So we're both basically have the same map, 19 by 15. We both have no obstacles in our, I'm allocating random values, but I'm resetting the timer. Theirs again has no obstacles. It creates, does the same thing, allocates random points for the starting and ends. It's creating a whole new object just like I am. I'm creating a whole new level. Although I'm not creating, yeah, no, that doesn't do anything. And it just calls find path. The only thing I can think of is that I really don't know. Also, I'm calling it twice. Hold on. That's super weird. Great, now it's like 10 times faster than mine. Wow. What the heck? Okay. Find path. Sets fields for start node and end node. Does that matter? Mine doesn't do that. They defer clearing the list when it's done. It's fine. Oh. I am not clearing the lists. Which means my lists are growing every time I iterate. Hold on. Hold on. Let's do something real quick. How's our close points clear? So now we're going to clear those. I hope that makes it a little better. Nope, it doesn't. Of course it doesn't matter. Why would it matter? How about setting those, what was it doing? It was setting some start and end nodes, but is it even, oh, there's an a.start node. It doesn't even do anything with it. So that doesn't even, that code's like just dead code. Cool. Up the end node, is that one referenced? That one is on the calculate node. Okay. Sure. Let's do it. Let's just add it. a.best is equal to best. And then we're, oh no, sorry, I'm L. And then we create that as being a node, or dest. Is equal to a point to D. How about dest? This one's, I have to dereference it because that one's a pointer. And then I think when my isEnd node, are they passing it in theirs? isEnd node. Yes, they are passing it. So the only time it's referenced is in that Manhattan, yeah, the calculate node. Okay, back to my calculate node. Wait a minute. Hold on, I have to open this side by side. Split right. All right, so I'm not doing the weighting stuff, so I basically removed that. I was doing destination. Again, this is such a small L.dest. So why do they, oh, they don't even pass it in. All right, so I'll get rid of that. Oop. So we're going to calculate that node. Don't need that anymore. It's not going to do anything. Nope. This is just bonkers. totally bonkers. I mean, what if I do? What if I just make all these pointer methods? I will be shocked if this makes a difference. If it does, I mean, I clearly don't understand Go if it does. Oh, I mean, I guess I'd have to because, oh, jeez. I mean, I should be doing that now that I'm setting properties on it, because otherwise it's just going to be different every time. But it still didn't make a difference. Cool. Just make sure clear is actually in. Yep, it's resetting that. Huh. Alright, so I'm just going to slowly make my code look exactly like theirs. Start node, we decided doesn't do anything. They're adding a node. I'm dereferencing it, but that shouldn't matter. Yeah. Although, who knows at this point? Open list is empty. Current point, get fmin node. Nil. Remove points, add points. Remove points, add points. Is end node. Is end node, current, and end node. Again, I'm passing in a pointer here. Shouldn't matter. Maybe it does. No, I don't think it does. Oh, I'm not putting, sorry, I'm dereferencing the pointer, so that shouldn't matter. Get node, get node, get neighbors, iterate over the neighbors, check if they contain the neighbor, continue, calculate. They are also passing in the address of contains, because it's modifying it, contains, add. So, okay, so this is all the same. Calculate node, I don't have that, and that really should not matter. I'm not gonna do that one. Manhattan, distance check, yep, same thing. GH, Manhattan distance, somewhere else is, where is their Manhattan distance? There it is. Both, yep, fine. Neighbor nodes, let's look at neighbor nodes. They're taking in a node, mine is a 0.2D. This is different because their up node was different. I mean, I already tried it. Doesn't matter if this is plus or minus, but for me, up is -1, not +1. But again, these things should not matter. Neighbor nodes is accessible. In my case, it is walkable. Contains node. Close list contains node. It's true. Get node path. Again, we're not spending time there. It's all being done in this CPU profile. And it just keeps getting worse every time I run it. What is going on with my implementation? I mean, if I can't figure this out, I'll probably just switch to converting all my points to nodes and just using theirs and just calling it a day, because this is just totally silly that I have to spend this much time on it. Where'd my test go? Okay. I mean, the other thing is maybe mine is still more complicated, but width and height is 1915. I bet I'm missing something super silly. Yeah. Oh, I didn't look at points versus list. So their list. Yep. Same thing. Points. These are all pointer methods. Yep. Shouldn't matter. Points. Appending. All of them. Remove. Gets the index. And then basically slices it out using append. Which is kind of weird, but that's what you do. get index node points, search node x, search node point y, x, yep. Contains is just calling get index. Is empty is just calling len. Clear. They're doing that. I mean, it doesn't matter. Make is going to do something, but just for funsies, set it to that. Get next. I don't think I'm even using that anymore. Delete that. And yeah, get index of min 8f, point to d node, -1, index, search if node f is less than last node f, last node of the other index. Yeah. Min inf, no node found. It's all exactly the same, except for theirs is fast and mine is slow. So, all right, if we're spending, actually, let's look at the CPU profile again, one more time, because I want to check the two, make dang sure that the function I'm spending time in. All right, so this is A star. Where's even mine? This doesn't even include mine. That's weird. Huh. Let's alright, let's do this. We're gonna skip theirs and run mine. Benchmark, skip, and then ours we're going to run and get the profile for that. Oh, I'm an idiot. That's why. I was running the wrong profile. Okay. So the major difference is my neighbor nodes spends time in get index. And theirs spends time in grow slice. I wonder if like something's being inlined in their version and not mine. So a good way to check, like let's assume that there's something different between my version and their version. So one thing we can do is use SSA func. So this is just an amazing part of the tooling, where if you define as an environment variable the name of an object or just a function, and then you build with it, it will spit out an HTML file with all of the compiler passes. So it'll give you, basically, as it's compiling, it'll run one pass, and then it'll give you the output of that, and then it'll show you as it goes along and basically gets to a static single assignment, which is basically trying to remove as many basic blocks and assignments of variables so that it's much easier to reason about. So, and it's faster. So we're going to do, what was that function that was super slow for me? Well, get neighbor nodes is where theirs goes kind of nuts. I don't know if I can compile. Can I build a test? I've never tried this before. No, I don't want to do that. How do I compile theirs? I guess I need to go to their... Can I copy this path? Is there any way to copy this? A star. Can't copy it. Alright, so it's in... Oh, it's going to be a pain in the butt. CD home, right there, go package, mod, GitHub, JPierre. Oh no, I just launched GitHub. That was weird. GitHub here, A star, and then we're going to do SSA. Oh, there's my password. Oh no, you know my test account password. Get out of here. That's weird. SSA. No, don't give me all this stuff. What are you doing? Okay. Oh, I know why. Because it's not from there. It's from over here. Alright. SSA func. We want A stars. Get neighbors, I think. A star dot get neighbor nodes. And then go build A star. Go. Undefined node. Oh, right. And we need to pass in a node, and I think probably list. So this should give us an SSA.html file, and it did not. And I don't know. Is this like write only folders on it? Why is that not giving me the file? The A star to temp. See. Oh. Star. What am I doing here? Wow, it is just not giving me that information. Am I not? Am I missing a go build? Yeah, it shouldn't matter. Go SSA func. I mean, it shouldn't matter that it's not exportable, right? This is really weird. Okay, let's just assume. How can I do this? How can I easily do this? Because I kind of need to know what their SSA looks like so I can compare it with mine. What if I just clone it? Yeah. Oh no, I think this is my other browser. Yeah, there we go. Code, clone. Clear. Can I just like, can I build it all? I don't even think I need that. Just do this. What is the deal? Why is it not letting me? Because it works fine for my other one. If I do this, was it broken now? What? Now it's broken. Game level. It should say spitting out SSH.html, and it's not, and I have no idea why. If we go back. Oh, there we go. What is it? Environments, go build, undefined. Named files must be Go files. Environments, go build, blah, command line arguments, dumped SSA to HTML. Yeah. This is exactly what I just ran. Maybe my system's just like totally buggered. I don't know what's going on. Anyways, luckily I saved them so we can look at some of them. Somewhere. Oh no, did I? Yeah, here it is. So what I have here, unfortunately I can't show. I'm just going to demo what this stuff is. So this is the source, and it gives you every single pass that the compiler does, all the way down to when it generates the static single assignment. So this is basically just the assembly of the Go code, and it's super nice because you can be like, oh, I wonder what this goes to, and then if you scroll back, he's like, oh, that's this line right here, and it's just crazy interesting just to see how the compiler does its passes and slowly like gets rid of information or adds information. Yeah, I feel like late nil check, loop rotate, stack frame, and trim. So it's just like iteratively getting the code smaller and smaller and more compact. And I couldn't find any major differences between when I guess it's not even the issue of passing it as an object instance versus passing it as a pointer to the method, but that was my first idea that's what it was, but apparently not. So I am at a total loss for what is going on with my code right now. Yeah, unfortunately I was hoping to demo some pathing stuff, but I got stuck with this debug session, which now my tools aren't even working anymore. So I probably just need to do a reboot or something. Yeah, that's kind of where I'm at. I guess I'm going to stay on for another 10 minutes and try to debug this, but yeah, let's see what I can figure out here. Okay, so let's see. Go back to level map. I don't want to do this. Like, I don't want to have game level be immutable. I want it to be immutable. I do not want it to be mutable. So I can reason that whenever I call stuff, like calling paths from cells, it's not modifying paths. And although I'm running everything from a single Go routine, so it shouldn't be too much of an issue, I just feel more comfortable knowing that there's no way these properties can get modified after they're initialized. So I'm going to set you back. That's done. I'm going to get rid of this garbage. I mean, I could probably just see if I can optimize at all. Get rid of those, get rid of that. Because a lot of these, I feel like I don't even need to pass in points. I think I can just like pass in the X and Y's and then just check my tile map, because I already have that there. So let's do that. Let's just get rid of all this stuff. See if we can reduce. In fact, but it needs a list of, it does need a closed list of unwalkables, but it doesn't need to be, it only needs to add unwalkables as paths that it's trying to navigate. So I think I can reduce that. So here's what I'm going to do. Go on to them. All right, close points, open points, that's fine. Open points, open points, open points. Yep. Yep. Calculate node. This one needs the destination again, because it needs to know node and dest. Right, so is endpoint, that's fine. So anytime I'm doing a check, like is walkable, I don't need to, I mean I do need to add if close points contains, I need with past. So I'm going to change that. Hide this one. These are the ones I'm going to work with. And I'm not going to work with that one. So what I'm going to do is, don't need to pointer that. Remove the current point, add the current point. Get numbers passed. I'm going to pass in the closed points. Right? And then I thought I even had, no, anyways, I'll check it in a second. Calculate that, pass in the points. So this, I don't think I need to do. Or no, I do need to do this, but only I can pass in just the X and Y. And the reason is I can check against my tiles instead, right? So in this case, I'm going to see if it contains oh yeah, I guess I do want to pass in the damn it. I was hoping I wouldn't have to do that. Alright, never mind. I do need to pass in the node, but I can also do if unwalkables. Oh, because I said it. I'm just going to do it by this. So this way I can just check directly, as opposed to adding it to a list and having it iterate over the list every time. I can just check if it's walkable and then return false if it's not. And then the close points will only contain those nodes that are ones that have been navigated already. So that should reduce the churn on iterating over that list, hopefully. Yeah. I was hoping I could only have to do this allocation if it is going to be added, but I have to pass in some stuff. Although I guess it contains no, I guess I do. Damn. Alright, let's see if this works. So just to make sure X is the rows, Y's, yeah. Sometimes I forget. Cool. Alright, let's run some tests here. Close points is undefined, which is true because it should be removed. Is walkable. Oh yeah, I can just delete this now. I can delete this one too. Nice. Index out of range with length 15. Huh. Didn't like that. It shouldn't have if width. My guess is it just crashed here, is that right? Is walkable past, yeah. Yep. Huh. Yeah, it's just checking. Yeah. That's weird. Why is it out of bounds? Index out of range, 15. Is that the X index or the Y index? Huh. I really don't know. All right. Good old log. X, Y. What you got for me? It is the X value is set too high. So that must be from the benchmark. Oh shoot. Yeah, that's not good. This needs to be like -1. How did that not crash before? Oh. There's a problem. That's why. Nope, definitely another problem. Still definitely a problem. 16, 18. Keep it one less. Now something really funky is going on. What is calling it with 15 and X? Oh, because I'm adding 1, of course. But it shouldn't be passing. Wow, what is going on here? Shouldn't be passing that. If node X is greater than the width minus 1 or height, should be returning false. Yep. Alright, well, I think I'm just going to end it here with a super sad note of not getting anything accomplished. But yeah, hopefully I will figure this out for the next stream, and I can show what I did wrong, because I guarantee it's something like super silly. Yeah, we'll see. Anyways, thanks for watching.